You're listening to the Weather Junkies.
Oh boy. Large wedge tornado coming up into Tuscaloosa.
A winter storm warning is in effect for our area.
So we can expect at least another 2 to 4 inches overnight. Then that snow
The National Weather Service in Huntsville has issued a tornado warning for northwestern Massachusetts.
14 to 22 inches of snow!
Hey everybody, welcome to another edition of the Weather Junkies, episode 79. My name's Dakota. Co-host Tyler cannot be with us tonight. Had a last minute thing that he had to go to. But it's me tonight, and we have an awesome guest in Sean Freeman, who is a grad student at Colorado State, where I am actually. So we're, I guess colleagues, or I don't know what the co-students, I guess, is the proper way to put it. But we're going to talk about a severe weather campaign using drones to observe them and collect data from them to learn more about formation and how severe storms develop. So we'll get into all that. But first, let's talk about some weather. We're both in Colorado tonight, and it's been super hot out here. I guess upper 90s the past few days, hit 100 in Boulder today, I saw. And yeah, so it hasn't been great. I know some people out here don't have AC, so that's been kind of sucky, including myself. Been spending a lot of time in the basement. But Sean, welcome to the show. And how would you describe the weather in Colorado today?
Well, Dakota, thank you for having me. It's been hot. I know that the AC was off in one of our buildings today, and I took a...
That was my building.
Yeah, it was your building, and I took a student in there to tour this morning, and I was miserable after about 5 minutes, so I can't imagine how you dealt with that.
Yeah, no, that's happened a few times this summer, and when I leave my house, I'm like, oh great, I get to go to AC, and then a few times it's let me down, and I'm like, oh man. But they got it fixed today, actually, so it was only the morning where it was off, and then it came on. But moral of the story, super hot, and it's been that way across a large chunk of the country. We got a nice ridge across the center of the United States, bringing hot air, humidity, pretty much from the Rockies all the way to the East Coast. I know they almost hit 100 in DC today. I think they topped off at 98 in Washington, DC. So pretty much just hot everywhere throughout the United States, I guess, east of the Rockies. So yeah, that's weather in our backyards. Let's get into the tweets. Let's just go for it. Talk about some of the things that were trending in the Weatherverse this past week. First up, I have a tweet from Corey Reppenhagen. He is a TV meteorologist in Denver. You can follow him at CRepWeather. That's CRepWX on Twitter. His tweet says, surprise tornado in Longmont today, shot by John Traxinger. Landspout or gustnado, can't see if it's attached to a cloud base. And he shows this video of a very, very small vortex funnel that's stretching from some cloud base, you can't really tell, to the surface. To me, it looks like a dust devil. Sean and I were talking before, and we didn't think the National Weather Service did a survey on it. Sean, were you? I was shocked when I saw this video because we live out here, and I wasn't really looking for that. I guess that kind of happens a lot here in Colorado. I just get a random weak, I don't know, dust devil or landspout.
Yeah, we saw this a few times during the field campaign. Typically, when you see something like this out here, it's not so narrow, it's not so tight, like a tight circulation like this one was. Now, it's a little bit hard to tell because the camera is very far away from whatever this is, but it seems rare to me that we get something this narrow, but I haven't been out here long enough to know for sure whether or not how rare that is out here.
Normally, I feel like once a year we'll get one of these, and maybe a little stronger, maybe actually associated with the supercell. And then you'll get a picture of one of these from the Denver airport, because it just seems like the spot where at least like once a year. I think the past 2 years they've had one. So I guess that's biasing me a little bit. But not this year. I guess just not the right place, right time.
Not the thing you want to see as you're about to fly out.
No, gosh, I'd be terrified. So actually, I wanted to go on a little side rant here about this tweet. So Corey actually posted this on Facebook, and with it, he posted this like long paragraph, and within that paragraph, he said the words severe tornadoes are not severe weather, and then he basically was making the point that there's not a severe thunderstorm warning when there's a tornado, because most of the time it's a tornado warning if the National Weather Service identifies the tornado properly, which they at this point they do a pretty good job of. And so like I could see what he was getting at, but tornadoes by definition are severe weather. And I looked at the comment section in that, and it was just miserable. People were saying like, wait a second, I always thought tornadoes were severe weather. They're not, they're destructive, blah, blah, blah. And for those of you that don't know, severe weather is considered hail larger than an inch, wind gusts greater than 58 mile per hour winds, and tornadoes. So it's just kind of a weird thing he did there. And I don't think it was the greatest like science communication. So Sean, you study severe weather for a living. What did you think about that whole passage?
I understand what he was getting at. I understand the point he was trying to make. It's very unlikely that whatever this was put anybody in danger, but the words that he used were not great. Saying that tornadoes are not severe weather is a great way of confusing people. Our warning and watch system is already incredibly confusing to people that don't have a meteorology background, and this is the kind of thing that's not helping. And it's just not. It just wasn't phrased the correct way. And I see that he did go out of his way in the comments to reply to most people that seemed confused, but he didn't seem to go out of his way to clarify exactly what he meant.
Yeah. I feel like this is a conversation that like would be better like within meteorologists, like in kind of like a smaller circle, not something that should be posted on his Facebook page that has, I don't know, 18,000 likes on it.
Yeah, and I understand that he just made a semantics mistake, and he could have done a better job of correcting it. But I think he seems to have understood what he did wrong.
Yeah.
I feel kind of bad for piling on to him, but this is the
I do too, because
this is the kind of thing that's important. People don't necessarily understand when they're in danger versus when they're not in danger, and this can make this is the kind of thing that people make life or death decisions based on, and they need to know. It needs to be very clear to people that don't have a meteorology background when they need to take action.
Yeah, no, I'm with you. It would have been nice for him to because you can edit Facebook posts. I understand not deleting it because it got a lot of shares, and he's on the news, and that's what it's all about. But maybe just tweaking it to make it a little clearer would have been good. But anyways, let's move on to the next tweet here. This is a not so humble brag. This tweet comes from Penn State Meteorology at PSU Meteo on Twitter. They say Penn State Meteorology continues weather forecasting dominance. Wow, that's a strong word. They earned their 6th straight national honor. So this is in a challenge. Well, it's properly named. It's called Weather Challenge. And it's a 20-week weather forecasting competition where basically the operators of Weather Challenge pick cities throughout the United States and you forecast for them. I've never done it. John, have you done Weather Challenge before?
I have done it once. It's very time consuming.
What do you forecast for?
From what I remember, it's been a couple of years. You forecast high temperature, low temperature, and rainfall.
Okay, gotcha.
I can't remember if this is the one where and maximum wind speeds. Yes,
Interesting. Okay. Yeah, so is it every weekday for 20 weeks?
I want to say it's Monday to Thursday.
Oh,
And
okay, so 4 days.
it's 20. It is 20 weeks, and each 2 week period it's somewhere different. So like this year, the first 2 week period was Key West, Florida, and then the next 2 week period was Harrisburg, Pennsylvania. So it really jumps all around the country. And then in the spring, I know this year they changed up how they selected their cities. So the cities are announced well in advance for the fall, but this year they selected some of their cities in the spring, basically last minute, to be wherever might be interesting at the time.
Oh, that's awesome.
So, but for the fall ones, you know where they are ahead of time, but that doesn't necessarily help you very much. It's very time consuming to do this well because of the amount of forecasting that requires every single day. So for Penn State to do so well, so many years in a row is really remarkable.
Yeah, so there's a reason that I guess there's a bunch of reasons they do well, but one of them is they actually have a class that's like dedicated to forecasting for this. I remember when I was a freshman, I think it was brand new. They had just started. So that would be, that's about I guess that's 7 years ago then. So I guess a year later they started winning. But basically it was like a 4-hour class that you took, and it was every weekday night except for Friday night. So Monday night, Tuesday night, Wednesday night, and maybe even it started Sunday night too, because you're forecasting for Monday. But you basically would go into a room and put your forecast together. And yeah, it's not for me, but it's definitely for people who want to forecast for a living. I'm sure some of the best forecasters out there did this in undergrad and still do it in grad school and maybe even while they're working. So yeah, kudos to Penn State for winning that again. It's pretty cool. We'll move on here to my final tweet, and it's kind of a string of tweets that I wanted to talk about. If you didn't know, Tropical Storm Don formed in the Atlantic, and given that our president's name is Donald, it's kind of a coincidence. There's no that wasn't on purpose. They named these storms well in advance. In fact, you can see the list, I think, all the way out to 2020 right now of the storms. In another coincidence, there was a tropical system in the Pacific named Hillary, spelled with one L, not two, like Clinton. But still, another coincidence, Hillary and Don, the two candidates for president, Republican and Democratic. So this spurred a whole bunch of chatter, obviously, not just in the weather community, but in general. The AP tweeted out on Twitter, AP Politics. You can follow them at AP_politics. And they quipped and they tweeted, Hurricane Center calls Tropical Storm Don small and not particularly well organized. I gotta say, this made me chuckle, still makes me chuckle. But this is language that the Hurricane Center uses often for storms, especially with one like Don. It was small, not very organized. But to tweet it from the politics account is kind of weird. It in a way it politicizes the Hurricane Center. It's giving them the assumption that they called it small, not particularly well organized, because they have some sort of political bias towards the Donald Trump, our president. So yeah, that was kind of weird. But then there was a bunch of backlash from both sides of the aisle, conservative and liberal meteorologists. You don't always know what someone leans, but if you're on Twitter long enough, you figure out kind of how people lean. Ryan Maui tweeted, you can follow him at Ryan Maui. He works for Weather Bell. He tweeted, looking forward to the Hurricane Center throwing shade with Tropical Storm Hillary. Right now, she's in a depression state. So he was kind of quipping about Hillary. But before that, he tweeted out, regardless, director job at National Hurricane Center was just posted, which it was at USA Jobs. He said, this position is completely apolitical. Media needs to respect that. That means keep your juvenile anti-Trump jokes to yourself. Don't sap the credibility of a world-class agency for your lame political agenda. And I think he has a point. I think if it wasn't AP politics, if it was AP like science or something, then that makes sense. So, they're talking about the storm. But in this case, it was kind of weird. I also thought it was kind of weird that he then tweeted about Hillary, but didn't really make any jokes about Donald. But that's just how it goes. Quite the coincidence, huh, Sean?
No comment. No, I mean, I think I completely agree with his first tweet. I thought that I think that we should really refrain from attempting to politicize this, because we've already had instances where the National Hurricane Center has been politicized. I remember last year with several hosts on talk radio saying that the the National Hurricane Center was blowing Matthew out of proportion to try to affect election. And I'm just worried that we're creeping more and more towards an era where people aren't going to believe the very factual weather information given by our government agencies. And anything like this just serves to make them seem political. And I am not a fan of that. And one more comment is that there's another good chance in 6 years we're going to see this exact same situation again, because they recycle these names. So in 6 years, we're also going to have the option to have a Hillary and a Don system.
Yeah, that's right, because neither of those will get retired.
Neither of those will get retired.
Yeah. That's funny. Well, we'll see what happens then, I guess.
Yeah.
So that'll do it for trending in the weatherverse this week. Another fun week in weather and climate. Sean, let's get to your work that you're doing right now. So just a brief intro of Sean. He got his bachelor's in meteorology and computer science from Florida State University. You're the second Florida State person we've had on in the past few weeks. We had Allie Keslick on.
Allie and I know each other. We had a lot of classes together at FSU.
Oh, nice. Yeah, Allie's great. Yeah, that's cool. I like getting diversity on the show because for a while there we were only bugging our friends, and I guess I'm still bugging my friends, but friends that didn't go to Penn State. And right now you are a grad student at Colorado State, studying severe weather, and particularly you're working on the Cloud X campaign that you and your team did this past year. So Sean, before we get into the campaign, how did you get into weather and what kind of sparked your interest there?
So I grew up in West Virginia until middle school. And my first memories of weather are watching the Weather Channel and watching Jim Cantori on the shores of, I don't even remember, some hurricane, and just being like, that's cool, I want to do that. And so I was the kid in my class in first grade who was tracking the hurricanes on the map in my school, and nobody else cared because we lived in West Virginia, and the chances of us getting hit with a hurricane in far western West Virginia are pretty much zero. So that's where it started, and it kind of just, I stayed on that path from there. I always knew that I wanted to do something in meteorology. And I realized pretty early on too that I had an affinity for technology. And so I thought, what's the best way I can combine meteorology and technology? And I figured out it's numerical modeling, but also cool new observing systems. And that's kind of been my passion, has been the weather and using technology to better understand the weather.
And so now your focus is severe weather. I guess tell us about how you came to grow towards that, because you said you grew up in West Virginia and then you went to Florida. It's two very different weather regimes down there compared to where you are now. What kind of led you to severe weather?
Yeah, that's a good question. I don't really know the answer myself. The severe weather was always the interesting thing. I've never really lived in a place that got something that was truly dangerous from a typical severe weather point of view. Tallahassee is obviously in a hurricane risk area, but after we moved from West Virginia to Kentucky, and so I've not really lived in anywhere that's had a real severe weather risk from anything other than floods. And so it's always the looking and seeing what's going on in the plains and seeing tornadoes, that's cool. It's not cool when it impacts anybody, but being able to see the beauty and power of nature is really fascinating to me. And that's kind of how I started in severe weather, and that's kind of why I've liked severe weather so much. It's just because that is the beauty of weather, and I get to see it with my own eyes, or model it with my computers, or sample it with whatever new observing systems.
So speaking of new observing systems, CloudX used a fleet of drones. Okay, so first of all, how many drones do you have, and what are the drones measuring, and where do you put them when you're out chasing?
So during CloudX, which is the CSU Convective Cloud Outflows and Updrafts experiment, we were all over northern Colorado and southern Wyoming and pretty far northwestern Nebraska, and we drove around in basically vans, and we would take our drones out. We flew a fleet of 6 drones during CloudX, and we would basically look for cold pools. So as storms, as severe storms especially, but any storm rains, the rainwater evaporates as it falls from the bottom of the cloud to the ground, and as it evaporates, it cools just the same way that sweat evaporates off of your body and cools you. So that cold air wants to sink, hot air wants to rise. So the cold air sinks, it hits the ground, and once it hits the ground, it spreads out from the ground because it can't go any further down in the ground. So it spreads out from the ground, and it basically creates these cold pools around the storm and ahead of the storm. So we know a decent amount about cold pools. We don't know a lot about their structures. We don't know a lot about exactly how they behave, especially on small scales. So what we were trying to do with the drones was, we have the drones instrumented with a pressure, temperature, and humidity sensor, some IR instruments, and a visible camera. And we flew them out in front of the cold pools, and we would fly in a special pattern in front of the cold pools. And we would let the cold pools pass us, and we'd let our drones basically do the heavy lifting and get really neat observations that we've never had of cold pools before. Because these cold pools are associated with storms, you can't just necessarily, if you want to get observations above the ground, you can't just erect a tower in front of a cold pool. That's impractical. And if you just erect a tower and hope cold pools come, Murphy's Law dictates that you'll never see a cold pool in the whole lifetime of the tower. And so being able to observe these cold pools above the ground is something that's not really been done a whole lot before, and especially on the small scales that we were looking at. In addition to our drones, which can only fly so high, we also launched weather balloons into the cold pools to try to get an understanding of the full deepness of the cold pools and the full structure of the cold pools.
So there's compared to like a structure or something like that, the drones have a lot of flexibility because you can take them and then put them up. What are some of the limitations of them, and have you had any incidents per se with since you're piloting them, and there are some winds there? I guess, what are the limitations, and have you had any incidents happen with them?
So our biggest limitation is actually the law. So the Federal Aviation Administration they control the skies in the United States, and we have to follow their rules for small unmanned aircraft systems, which is a fancy word for drones. And part of those rules are that you have to stay under 400 feet above ground level. And 400 feet might sound like a lot, but it's not really a lot in the scale of the atmosphere. It does give us a whole different perspective than we've had before, and being able to observe at 400 feet and we've been looking at the data, has been really remarkable, and we do see a different picture than we do on the ground. But it's always better to go higher, and the drones are technically capable of going higher, but the FAA has pretty strict rules about that. Now we've gotten a waiver to be able to fly up to 1,200 feet above ground in certain areas. And that waiver has been enormously helpful, and we're very grateful that the FAA worked with us to issue us this waiver. But the waiver is still somewhat limiting in where we can deploy. So it's always our main constraint right now is the law. The other main constraint for us is winds, as you mentioned. We've got a pretty hard limit on the drones of about, well, I say pretty hard, and I say about 40 miles an hour is about our limit with the drones. They will start to drift over about 40, 45 miles an hour, as it says in the spec sheet. And as long as when they start to drift, we start to get very uncomfortable very quickly, and we try to bring them back in. We also don't have the drones get rained on, but that's a choice, not necessarily a hard requirement.
And you're the keeper of them. Have you become attached to them?
Yes, I have. I have become somewhat attached to them. Anytime anything odd happens to them, I run over to my babies and wonder what's wrong.
And how many are there again?
So we fly 6 in formation, and obviously we have a few as backup.
And so there are 6 people piloting them at the same time.
Yes, our field campaign actually got 7 pilots trained, including myself. So we have a backup pilot, but there's always 6 pilots flying it at a time. And then when we activate our waiver and we fly above 400 feet, we are required to have a visual observer for each drone. So we have that as well, just somebody basically to scan the sky and warn us of anything going on in the oncoming aircraft or anything like that.
Wow. So what's the communication like during that? I feel like that's a lot to organize and coordinate, especially when you have a storm that you're in an area where there are probably storms. The storm that you're looking at, you're probably behind it, presumably. But so what's the coordination like with an event like that?
Yeah, that's a great question. During the field campaign, we had enormous support from our forecasting and operations team. We had between 2 and 4 people actually at the the Colorado State University Chill radar, which is a world-class radar located in Greeley, Colorado, and they were using Chill to be able to get us up-to-the-minute information about where the storm is, what's going on, do we need to get out of here, and if so, how do we get out of there? And we've had the very dedicated forecasters working with us. We had an array of communications technologies with us. And then even on the ground, we had a lot of extra people just there to support and to understand what's going on, both from the operations center and just being able to look at it themselves. So communication is an issue with this, but we have made great strides to overcome any communications issues, and we've taken a lot of time to make sure that our communications are top notch. That's communication in the field is so important for safety and for getting good science that we spent a lot of time early on just trying to figure that out. And we actually this year was our phase 2, and last year we had our phase 1 for 2 weeks in last July, and one of the biggest things that we did during that time was just test our communications to the limit and make sure we had excellent communications everywhere that we were going to be.
Storm chasing is a fickle thing because the ingredients don't always line up, and or you're in the wrong spot. How successful were you in your campaign this year?
We had some frustrating days. There was at least a couple days where we didn't go out and we should have. And there were a couple days where we went out and we sat in a parking lot or in a field or on a dirt road somewhere, and we just looked at the clouds as they passed by because they were just fair weather cumulus. Our success rate was pretty good for a field campaign. I don't remember what our success rate was, but it was very high for a field campaign. I'd say over 2/3 of our cases, the days that we went out were good to excellent days. And I think that what allowed us to do that is that we were pretty flexible in our goals. So it's not just the drones, which is the part that I like to talk about is the drones. We also did some really cool work with launching balloons into thunderstorm updrafts. And being able to rotate between the goals of getting at cold pools and the goals of getting at updrafts allowed us a lot of flexibility and the ability to basically turn any bad day into something workable for us.
So now you have all the data from this campaign. What are you going to do with it?
That's a good question. We're going to go where the science takes us, as with any research project. I know that several of us are working on analyzing the data right now. We're trying to get an idea of what we can do with this, just because there is so much we collected so much cool data that's never really been collected before, and we've got this really unique opportunity to be able to analyze it. And so we're at the stage now where we're really getting into the nitty-gritty of the data, but it's one of those things that I'm sure we'll be working on this for years to come, just because of the amount of really cool data that we got.
And the end goal is to improve modeling and forecasting of these storms.
Right, and that's the end goal of almost every research project, is to improve forecasting, whether it be on a short time scale or a long time scale. And that's really been our goal here, is to get information about cold pools and updrafts, because those are two things that models do not do well. They don't simulate cold pools very well, and they don't simulate updrafts very well because of resolution, microphysics, and we don't really know why they don't simulate them very well, but there's a whole host of things that could be the reason. And we're going to take these observations and compare to models and be able to understand what our models are getting right, what our models are getting wrong, and using that information, being able to improve models in the long term. But as with any research, it takes a few steps between our observations, between me flying a drone in Albin, Wyoming, and your models getting better. So, but it's working there.
Is this type of field campaign going to be like an annual thing?
This specific one is not going to continue past this year. As of right now, there's no plans to continue it. I do think that using drones and atmospheric science research is something that's going to definitely continue everywhere, essentially. There was an NCAR symposium, or summit, I guess, about drones in February. And there's a lot of people both interested and already using drones in research about the weather, about climate, and about atmospheric chemistry. So drones are definitely a growth field inside of meteorology and atmospheric science as a whole. But this specific field project is going to end.
Besides drones, could you talk about other unique ways of observing severe weather or anything in our atmosphere?
There's so many different ways, and there's so many new things coming out just because of technology, from people making really small radars to the people working on using cell phones to get pressure and temperature measurements around the world. I saw a blog post by Paul Markowski at Penn State, who is using a novel weather balloon system to be able to. They launched like 30-something weather balloons at one time into a storm, and being able to get a full picture of that is, there's all sorts of new different observing systems and enabled by technology in weather that is just remarkable. And I even forgot to mention CubeSats, which is a huge innovation, and being able to launch a satellite that's a lot smaller than traditional satellites, and being able to have the instruments miniaturized to fit on that platform. And it's just amazing what new technology has done for our field. And it's not just in observing either. I mean, even 5 or 6 years ago, when I started doing weather research using models, the computers have improved dramatically since then, and the storage space has improved dramatically. Everything's growing at exponential rates always, and it's just been amazing. It's always amazing to me what we can do now versus what we could do even 3 or 4 years ago. I mean, we couldn't have even thought about using drones even 3 or 4 years ago in our specific application. There's some people that have been doing drones for a lot longer than us, that have, like the University of Colorado has been doing things with drones for a lot longer, but nothing we use multi-copters, so they're able to stay in one place at a time, instead of having to fly around like a fixed wing drone would. And so that technology wasn't even really there and able to be used in something like this even 5 or 6 years ago. So it's really been remarkable how many things are changing and how many things are improving because of technology.
Yeah, I feel like it comes up. It's crazy that we have such high quality radar data on our phones. Like, blows my mind. But the thing is, I can't imagine it any other way, just because we kind of grew up in this age where everything was on your phone, and weather data was on your phone. Soon enough, we're going to be able to look at some of this like 30-second GOES data on our phones. Seems kind of crazy right now, but I'm sure it's going to happen eventually. And yeah, so yeah, the field is definitely growing and the technology is getting better and faster. So just better things for our field. Although some people talk about, are humans going to have a role? And I think they always will, but maybe some tasks will be computers. So I guess what's your next step forward? You're getting your master's, because I know at CSU you get your master's, and then you move on to PhD. Do you have plans for your future after your master's?
I would like to stay on and get my PhD, and beyond that, I don't know yet. Yeah, but I'd like to stay on and get my PhD. Research is something that I really love, and I'd really like to stay in research in one form or another. And I really like research, and I really like talking to people about science. So,
think you'll stay severe weather centered?
Yeah, something with severe weather, something with cloud physics, something with drones. Would any of those I would be perfectly happy with. I'm pretty flexible in terms of what I do in the weather enterprise, as long as it's related to severe weather in some way. It doesn't really matter to me how it's related to severe weather, but I really liked cloud physics, and I really like being able to look at like storm physics and storm dynamics too. So anything in that area I would be thrilled with. So, but I'm just happy to be here. I'm just happy to be able to do research and be able to fly drones and manage drones and understand all of that. I'm honestly very happy where I am.
Off-topic question: what's your favorite thing about living in Colorado?
Ooh, favorite thing about living in Colorado. I've got to say access to the mountains, which I'm sure is a very generic answer, but it's everything that comes with access to the mountains. It's the hiking in the summer and fall, and it's the skiing in the winter and the spring, and it's this is just so beautiful to live here and just be able to look at the mountains every day. And I can honestly say that I still haven't gotten used to looking out my window and seeing mountains, and that's still really cool to me, whether it should be or not. Yeah.
Do you have a least favorite thing about living in Colorado?
When I was at Florida State, I really liked not having to deal with cold and snow. It was a really cold day when it was 50 degrees outside, and so I really truly miss that. And I complain relentlessly in the winter about how cold it gets. So if I had to change anything, I'd say in the plains, it'd be great if it just didn't get cold in the winter, but it stayed cold in the mountains, so I would get snow and be able to ski. So yeah. It's a tough. You can't have both. So it's all about trade-offs. And I think I'm willing to make that trade-off as long as I'm allowed to complain about it.
At least it's sunny, because there are some places that are cold and cloudy, and that's tough.
Yes, at least it's sunny and the snow doesn't stick around very long.
Yeah.
So I'm plenty happy with that.
So last question, and we ask everyone who comes on the show this question. If you were to give some advice to someone up and coming, let's say research, since you're a grad student, maybe even a fellow grad student, maybe someone doing research as an undergrad trying to get their bachelor's degree, what advice would that be?
My general life advice is keep your door open. You never know what might come through it. Always be willing to take opportunities whenever they come knocking. You never know when you might end up flying drones for your research or doing something else really cool. So many things in my life have come about just because I've been willing to listen and willing to apply to things. And I think that's one other thing, is that you have to believe in yourself. And I realize coming out of my mouth that sounds so generic, but I really mean it, that you should believe in yourself and you should apply for things. Whatever you think that you might want to do. Like if you think that you might want to get a Holling scholarship and do research in a National Weather Service office or something like that, apply for it. You might not get it, but in the process of applying for it, you're going to understand, having to write your thoughts and your hopes and dreams down on paper, it's going to make you understand a lot more about what you want to do and why you want to do it. And that'll help guide you in your future path. And don't get bummed if you don't get something. I know that that's very hard to do. I struggle with that myself a lot, but it happens to everybody. Everybody at some point in their lives has applied for something and not gotten it. Even if it happens to you a lot, it just means that the right opportunity hasn't come around yet. The right fit hasn't been found yet. And eventually you'll find the right fit wherever that is.
I really like the keep your door open. You never know who might come through it. Sound advice, Sean. Thanks so much for joining us tonight.
Absolutely. It's great to be here.
Where can people find you on Twitter or on the internet or wherever you want them to find you?
I don't tweet much, but I'm at WXSean, WXSEAN. And I'm on the internet at my advisors page. If you Google Sean Freeman, Colorado State University, you'll find me. But you can also go to my website, which will redirect you to my advisors page, SeanWFreeman.com. That's SEAN, the letter W, FREEMAN.com. And that should take you to my advisors page.
Awesome. And if you want to find us on Twitter, you can follow us at the WX Junkies. We're also on Facebook. Give us a like there. You can listen to this podcast on iTunes, Stitcher, pretty much anywhere. Go ahead and give us a rating and or a review. If you could, we'd love hearing from you. Next week, we don't have anyone scheduled yet, but we will have someone for you. And presumably Tyler will be back. So I'll have a full show next week, Thursday, 8 p.m. Eastern. So for myself and for Sean, thanks for joining us tonight.
Cow. I gotta go, Julia. We got cows.